To obtain a good quality zinc sulfide phosphor, we need to start with a relatively pure source of zinc 2+ ions. And what we're going to do today is make a zinc sulfate solution using zinc oxide obtained from a ceramic supply house. And we're going to react it with sulfuric acid and make a zinc sulfate solution, which we will further purify using various techniques. So what I have set up here is my hot plate stirrer. On top of that is a 600 milliliter beaker, and above it is a separatory funnel filled with 31 grams of concentrated sulfuric acid from the hardware store. So what I'm going to do next is add 25 grams of zinc oxide powder, slurry it with deionized water, and then slowly start to drip the sulfuric acid into the beaker and let the two react. In goes the zinc oxide. Add some water. I've made the zinc oxide slurry with about 150 milliliters of water, and now I'm going to open the stopcock and let the sulfuric acid drip in very slowly. This is a very exothermic reaction, so be very careful when you do this, as the beaker will heat up, and if you add it too fast it can blow. So a nice slow drip rate, and we'll let that drain out. Once the sulfuric acid has been added, keep stirring until most of the zinc oxide is dissolved, and periodically check the pH of the solution. We want it somewhat neutral, or perhaps around 6, and at the moment all I have is pH paper to test it with. As you can see, it's still red, and there's still a little bit of zinc oxide on the bottom of the beaker. So I'm going to let this stir for another couple of minutes and see if the pH will rise. After about 5 more minutes of stirring, the pH rose to about 6, and that's where we want it. So I'm going to stop stirring, set up my filtration setup, and filter the solution. Alright, I have my filtration set up. We're just going to use gravity filtration, and I'm using a larger funnel to hold my small funnel so that I can use my ring. I'm going to put a magnet underneath the beaker to keep my stir bar in place, and I'll filter the solution. After the first filtration, the solution was still cloudy, so I diluted it down to, or brought the volume to 200 milliliters and filtered it again over the same filter, and what I got was a nice clear solution. What I have set up now is a separatory funnel with 0.1 grams of potassium permanganate dissolved in 60 milliliters of water, and what we're going to do is drip that into our zinc sulfate solution to try and precipitate any soluble iron impurities that we may have. And what I'm going to do is turn the stirring on, turn on low heat, and adjust this so we have a very nice slow drip rate. As you can see, the pink color disappears. That means we're oxidizing something in solution. Here we go. And once that pink color is persistent, I'll stop the addition. I've added several milliliters of potassium permanganate solution. As you can see, our zinc sulfate solution has turned reddish orange due to the precipitation of manganese dioxide. The solution has turned a nice red, and I'm going to let it stir for an hour and see what happens to the color. After about 15 minutes, the solution went from red to a brown color, so I'm going to add a little bit more potassium permanganate solution. The solution's been stirring and boiling for about an hour, and I'm going to set up vacuum filtration and filter the solution and see if we have any permanganate ion in the solution left. I've set up my vacuum filtration and going to filter our solution that has precipitants floating around. So I'm going to turn on the vacuum and filter this. After filtering the solution 4 times through the same filter paper, I obtained this clear pink solution. Now we're going to put it back on the stirrer, and we're going to add 10 grams of zinc powder. This powder was made from the zinc oxide, so it's not of exceptional purity, but that shouldn't matter. And what this will do will precipitate any copper or cadmium in the solution, and hopefully we'll get rid of this pink color as well. I'm adding a large excess of zinc because the purity of the zinc powder isn't that great, so I want to make sure I have enough zinc in the solution to replace all the copper and cadmium ions. And I'll leave this stirring for about 30 minutes. I stirred the solution for about half an hour with the zinc powder. As you can see, it no longer has a pinkish color, but it has the fine zinc suspended in it. So I'm just going to filter this again. After filtering the zinc powder out of the solution, I replaced it with a new filter paper and filtered it 4 more times, and the result was this nice clear solution. And we'll pour this in a bottle and keep it for the next step, in which we precipitate out zinc sulfide.